Hey, what's up, guys? We're looking at our Unit 6 homework for the first 4 lessons, and they throw back. Sorry about the interruption there. We had a bell go off. But we're looking at Unit 6, lessons 1 through 4, and the first question is a throwback to circles, which we have not talked about in a while. So, real quick, let's review circles. You've got two different parts that we need to be familiar with: the diameter, which would be here all the way across, and then of course you've got the radius, which would be halfway from center to edge. And it also mentions another part, I guess there's a third part, the circumference, which is actually just the distance around it. So those are the three things. And we also talked about another thing during that unit, which was area, how much space is inside. So we had formulas for all of these. Obviously, diameter is twice the length of radius, but circumference is pi times diameter, and area is found by doing pi times radius squared. So that should help us answer this question. Lynn and Tyler are drawing circles. Tyler's circle has twice the diameter. So if this is Lynn's circle, then Tyler's probably looks about like this. So if this is D, and then Tyler's is twice the size, and it says Tyler thinks that his circle will have twice the area of Lynn's circle as well. Do you agree? Well, we talked about this pretty in depth whenever we went over it, but you might have forgotten, so let's plug in some fake numbers and see. If I was to find the area of these two circles, let's just make up some numbers. Let's say that the diameter is 2 of Lynn's, which would make Tyler's diameter equal 4. If these things were true, then Lynn's radius would be equal to 1, half the length of that, and Tyler's would be equal to 2. And what we would do is we would square the radius and multiply it by pi, as this suggests right here. So the area of Lynn's circle would be pi times radius squared, and the area of Tyler's would be pi times his radius, which in this case would be 2 squared. 1 squared is 1, so this would be equal to 1 times pi, or just pi area. And this one would be 2 squared, which is 4, or 4 pi's. And this is not twice as much area, it's actually 4 times bigger. We learned this whenever we studied it, was that the area of a circle, when the lengths get doubled, you take the square of that relationship and you have the size that the area grows. That just because the length of the circle doubles does not mean the area does. So we do not agree. No, the area is 4 times bigger, because 2 squared is 4. And that's the answer to number 1.